circuits, starting lecture 14 with respect to fundamentals of electrical circuits. In the previous session that I discussed about how to solve the questions based on the infinite ladder network. One more important model for any computer exams point of view, mainly for GATE and ESE point of view. If any infinite grid is given, then how to solve the different models of questions that is based on the infinite grid. After completing this infinite grid concept, you have to see the concept of series connection of the bulbs and parallel connection of the bulbs. Students, all of you concentrate. Can anybody answer this? The answer for this question. In general, the infinite grid problems are solved by using superposition theorem. This is solved by using superposition theorem. Superposition theorem. How to solve by using the superposition theorem. Yeah, this is the given grid. Find the equivalent resistance between A and B. Here the question is asking how to find the equivalent resistance between A and B. Then to find the equivalent resistance between A and B for a given infinite grid, take one point is at one point current is entering, the another point current is leaving. Here I am taking, let us assume that at this point the current is entering, the current is driven by some voltage source. This is the method you have to follow to find the equivalent resistance. That this is the voltage source, it driving the current of I. Take one point is current entering point, take another point is current leaving point. First I am taking current entering, then you have to take the current leaving. Let in this case I am taking VA B1. Then the next case you have to take the voltage of VA B2. Yes. Now this is the current entering. All are equal resistances. Then current is equally divided. How many resistances are there? 4 resistances. 1, 2, 3, 4. The current is equally divided. Then what about this current, friends? This is I by 4. What about this current? This also I by 4. What about this current? This also I by 4. And this also I by 4. This is equally divided. Now what is the current passing through this resistance? That is I by 4. Now I am finding the what is the voltage across these terminals, that is A and B. That I am assuming that VA B1. VA B1 equal to, the current is I by 4, the resistance is R, that is I by 4 into R. This is case 1 you have to take. This is the current. Whatever the current is entering, that is leaving at B terminal. Because the question is asking, you have to find the equivalent resistance between A and B. Here I am taking current is entering at A, means whatever the current is leaving at B. Now we have to take the case 2. Let the current is leaving at B. Now the current is leaving. This is I. This I current is leaving means what about this current? This is I by 4. And this also I by 4. This also I by 4. This also I by 4. Then only the sum becomes I. Here the current is entering. Then you have to take this is the current leaving part. Then this I by 4, I by 4, I by 4, I by 4. Sum of these 4 currents, I by 4 plus I by 4 plus I by 4, that is I is leaving. But you have to find the resistance between A and B terminals. That's why you find the what is first I am finding the what is the voltage. This is VA B2. Then you have to find this is case 2 now. That's why I'm taking as a VA B2. This is case 2 you have to take. This I am solving by using superposition theorem. This you have to take case 1. Then what is VA B2? VA B2 is also again same one. Because what is the current in this resistance? I by 4. The resistance is R. That is I by 4 into R. I by 4 into R. Then the resultant VAB. This VAB equal to VAB1 plus VAB2. VAB1 plus VAB. What is VAB1 you calculated? That is I by 4 into R. What is VAB2 calculated? That is I by 4 into R. Then take I is common. Then VAB equal to this I into R by 4 plus R by 4. This is equal to I into R by 2. Bring this I into the denominator. VAB by I equal to R by 2. This is the voltage across AB terminal by current. This gives the RAB. This is the equivalent resistance between the A and B terminals. What is the equivalent resistance between A and B terminals? We got R by 2. Then which option is correct? This is how to see. Options are not given. Then you have to take RAB equal to R by 2. Sir, concept very simple. First, see the question. What it is asking? Find the equivalent resistance between A and B terminals. Then, in this A and B terminals, take one point is current entering, take another point is current leaving. Then I'm taking current entering is A point, current leaving is B point. Now, at this point, I'm assuming that I current is entering because of 4 resistors. This is equally divided I by 4. Then what is the current is passing between A and B? I by 4. What is the resistance R? then VAB1 equal to I by 4 into R. Then take this point is leaving. If you take this point is leaving, I current is leaving means I by 4, I by 4, I by 4, I by 4 is entering. Then only I current is leaving. The sum of these 4 currents is equal to I. Again, check what is the current in this AB terminals. That is I by 4. What is the resistance? R. Again, voltage drop is I by 4. Then VAB, the total VAB equal to VAB1 plus VAB. Then I by 4 into R plus I by 4 into R. Then resultant equal to I into R by 2. You bring this I into the denominator. That is voltage by current. That gives the resistance between A and B terminals. I got the RAB equal to R by. Clear? That you have to concentrate. Can anybody answer this question? Same model only. Find RAB. This is the one of the infinite grid. Here it is asking that RAB. Same procedure you have to apply. One is current entering. The another one is current leaving. This problem and this problem is same. But here they give more number of resistors. But finally you have to see here. The current is, this is I by 4, I by 4, I by 4, I by 4. This is R means I by 4 into R. Then here also same concept you have to apply. Then we can get the RAB equal to R. Clear? This is I. Then what is the current here? I by 4. 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 You get same answer. Then I by 4 into R. VAB1 equal to I by 4 into R. Then current leaving now. This also I by 4. This also I by 4. This also I by 4. Yeah, this is I. Then this is I by 4. This also I by 4. This also I by 4, students. This also I by 4. And finally, we can get a VAB equal to, students, VAB1 plus VAB2 only. Then what is VAB1? I by 4 into R plus what is VAB2, friends? That is I by 4 into R. You can write like this. VAB equal to, that is I into R by 2. You bring this I this side, then VAB by I, this is equal to RAB, this is equal to R by 2. How to solve the questions with respect to ladder network, previous session that I given in detail. How to solve the question based on the infinite grid, like this only how to question. Can anybody answer this one? You have to find the RBC. Whatever it is asked, any terminals, between any terminals it is asked, simply remember, one is entering point, another one is leaving point. Here it is asking that RBC. Then you have to take the one is entering point, another is leaving point. Then I'm explaining solution this. This is the entering point I am taking. This is the entering point. But between B and C, you have to find. Between B and C. Between B and C means you go like this or like this. Any path you take. This total voltage you calculate or this total voltage you calculate. Because here it is asking that between B and C, not between this point and this point. Here it is asking that between these 2 points. Now let this is the entering current. Then I is entering is, this is I by 4, it is a leaving. This also I by 4 is leaving. This also I by 4 is leaving. And this is I by 4 is leaving. Now here the entering current is I by 4. This I by 4. From this I by 4, how many resistors? 3 resistors. 3 resistors equally divided now. Then I by 12. This I by 12. This is I by 12. And this is I by 2. Correct? Entering current equal to sum of the leaving currents. We can add I by 12 plus I by 12 plus I by 12. Finally, we can get I by 4. KCL must be satisfied at any node. Here, what is the entering current? I by 4. If I by 4 is entering, remaining 3 resistance, I by 12 is leaving now. This is I by 12, this I by 12, this is I by 12. Now, you have to find what is VBC, VBC1. Let us assume that this is VBC1. Can you find what is the VBC1, friends? This is case 1 I am taking. One is entering, another one is leaving. Case 1. What is VBC1? I by 4 into R. Yes, plus I by 12 into R. Understood? I by 12 into R. This is I by 4 is leaving. Here I by 4 is entering means remaining 3 resistors are there now. I by 12 is. This is I by 12 into R. This total, or you can calculate this also. You go through this path or this path, you can get same. I by 4 into R plus I by 12 into R. This is case 1. Then case 2, you have to take the leaving. Case 2. At which terminal? One terminal is entering, another terminal is leaving. That this is the I is leaving. This I is leaving. This I is leaving. Now consider the currents. What are the currents here? The resistances. If I current is leaving, what are the currents? Come on, students, wait. Yeah. This is I current is leaving means this is I by 4 now. This also I by 4. 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 Because I current is leaving means if it is I by 4, this is I by 4, then what about these currents? I current is leaving means What about this current source? What about this current? This is I by 12. This is I by 12. This is I by 12. Then only it is I by 4 now. Here I current is leaving. Then it is I by 4. This is I by 4. This is I by 4. This is I by 4. If it is I by 4, what are the currents at this node? I by 12, I by 12. This is I. Now apply KVL here. You take VBC2 because it's a case 2, VBC2. Same. B2C now. I by 12 into R. I by 12 into R plus. What is the current here? This is I by 4. I by 4 into R. It's I by 12 into R plus I by 4 into R. Then resultant VBC you have to calculate. That is VBC1 plus VBC2. VBC1 plus VBC. What is VBC1 you calculated? That is I by R plus I by 12 into R. I by R plus, sorry, I by 4 into R plus I by 12 into R plus. What is VBC2 students? That is I by 12 into R plus I by 4 into R. Add these two. What you get? VBC equal to, that is I by 2 into R. Add these two plus I by 6 into R. I by 6 into R. Then you simplify this. What the VBC you can get? Take the LCM is 6. Then what you can get? That is 4 I by 6. Is correct? LCM is 6 now. That is 4 I by 6 into R. That is 2 by 3 I or 2 by, that is 2 I by 3 into R. Bring this I into the denominator. VBC by I equal to 2 by 3 into R. This is equal to RBC. The equivalent resistance between B and C terminals is 2 by 3 into R. 2 by 3 into R. That is option A is correct. Sir, between any terminals it is asked. Between any terminals it is asked. Just you take, one is entering, one terminal is entering, another terminal is leaving. Current entering is I, current leaving is also I. Then according to that number of resistors are present, you have to take the currents. See, in this case, leaving case, I taken this is leaving current is I means how many resistors are connected to this node? 4 resistors. Now, that's why I by 4, I by 4, I by 4. 4 resistors. This is I by 4 means what are the currents entering at this node? I by 12, I by 12, I by 12. Then only it is I by 4. Then only it is I by 4. Then it is I by 2. What is current here? I by 2. Then apply KVL here. I by 12 into R plus I by 4 into R. That is VBC. Like this, you have to calculate the equivalent resistance between the B and C terminals. This you try homework for practice. Take each one is one resistance. If each branch resistance is R ohms, this is R ohms, this is R ohms, this is also R ohms, this is also R ohms. Each branch is R ohms. Find RXY. That is, you have to find RXY. RXY means one is entering, another one is leaving. You take entering and leaving. That is one question. I entering students. Here I is entering. If I is entering here, then you have to take how many branches are leaving here? This 4 now. I by 4, I by 4, I by 4, I by 4. Again I by 4. This is I by 4 entering. This I by 4 entering. Then which is leaving? I by 12, I by 12, I by 12 is leaving. Then between X and Y only you have to calculate. Next, if a current of 1 ampere is injected at X, 1 ampere is injected at X and connected at Z, determine the current in branch XZ. You have to find what the current between the XZ. Determine the current. That branch current also you have to calculate. Same procedure you have to follow. Then solve these two. After solving this, if any doubts, you can share your doubts in my Telegram channel. I already given the Telegram channel. Okay. If you want, I will extend the detailed solution also. Just for practice purpose, I already explained 3 questions. With that knowledge, you try to solve these models of questions. I told already, take one point is entering, another point is leaving. Next. This also you have to take. If each branch resistance is R ohms, find RAB and RAC. You find RAB. Entering. A is entering, B is leaving. And RAB and RAC. A is entering, C is leaving. RAC. Then you find. This indicates each branch is R ohm resistance. Each branch is indicating the R ohm source. That you have to write. This also I'm giving for practice for you. Practice these questions. These are the models with respect to infinite. Students, one more important concept with respect to fundamentals of electrical circuits, that is connection of bulbs. Bulbs concept is also very important. Connection of the bulbs. Mainly, we know that the bulbs are connected in series connection and we also connect in parallel connection. If the bulbs are connected in series, what are the observations? If the bulbs are connected in parallel, the observations that I have to discuss in this. Let's consider the voltage rating of the bulb is V and power rating is P. If single bulb is given, let's consider the voltage rating of bulb is V the voltage rating of bulb is V, and power rating is P. Power rating is P. If the resistance of the bulb is R, then how to write the power rating? P equal to V square by R. How to write the rating of the bulb is P equal to V square by R. Resistance of bulb is calculated based on the rated voltage. Then from this you have to calculate what the resistance of the bulb. This R equal to V square by P. And we can represent the bulbs like this using the symbol like this, and represent the bulb. This is the representation of the bulbs. Theoretically, you have to represent the bulb like this. Yeah, this is the power rating, P equal to V square by R. Once you know the rating of the bulb, how to calculate the resistance equal to V square by P. Now let's consider the series connection of the bulbs. The first concept is the series connection of the bulbs. Let's consider two bulbs are connected in series. These are the two bulbs connected in series. Across these two bulbs, let the rated voltage is VR. We are applied the rated voltage is VR. Let the voltage rating of each bulb is the voltage rating of each bulb is V, and bulb 1 power rating is P1 and bulb 2 power rating is P. Let assume power rating of bulb 1. So this is bulb 1 and this is bulb 2. The power rating of bulb 1 is P1. And let assume that its voltage rating is V. That is, two bulbs are having the same rating. Let assume power rating of bulb 1 is P1 and power rating of bulb 2. Power rating of bulb 2 is P2. Let the voltage rating of each bulb is V. Voltage rating of each bulb is V. Then let the resistance of bulb 1 is R1. This bulb 1 resistance is R1. The resistance of bulb 2 is R2. Then how to calculate R1 and R2? We know that P1 equal to V square by R1. From this, R1 equal to resistance V square by P1. Like this, you have to calculate the resistance of the bulb. P2 equal to V square by R2. From this, what is R2 equal to V square by P2? Where VR equal to rated applied voltage. Rated supply voltage or applied voltage. Supply voltage. Don't confuse here. VR is the supply voltage and V is the rating of the each bulb. This bulb rating V, I taken both the bulbs are having the same rating. With this assumption I am explaining that both the bulbs are having the same rating. Now, the resistance of bulb 1 is R1, the resistance of bulb 2 is R2, friends. Now, what is the current in this series combination? In series combination, current remains constant. Then how to write I equal to? From this, you have to write I equal to VR by R1 plus R2. I equal to, that is VR by R1 plus R2. Then what is the power consumed by bulb 1? Power consumed by bulb 1. Power consumed by bulb 1. That is P consume 1. The power consumed by bulb 1 is, how to calculate the power consumed by bulb 1? I square into R1. The current remains constant, that is I square into R. What is the power consumed by bulb 2? You have to calculate the power consumed by bulb 2. Power consumed by bulb 2. Because here current is constant. Series connection, power consumed by bulb 2. P consumed 2 equal to I square into R. Power consumed by bulb 1 and power consumed by bulb 2. Then what is the total power consumption? Therefore, total power consumption equal to total power consumption equal to that is I square into R1 plus I square into R2. I square into R1 plus I square into R2. That is the power consumed by total power consumption equal to, this is PT. That is the total power consumption. But don't confuse here. Power rating is different. Power consumption is different. Where P1, P2 are the ratings of the bulbs. Once it is connected, because of resistance of the each bulb, it consumes the some power. Yeah, this is the power consumption. That is I square into R1 is the power consumed by bulb 1. I square into R2 is the power consumed by bulb. Then what is the observation here, friends? The power consumption, here I am giving a note point. the power consumption is proportional to I square into R1, I square into R1. This is proportional to I square into, shall I write R1 equal to, from this one, R1 equal to V square by this one. R1 equal to V square by P1. No? That is V square by P1. That means what is the observation here? The power consumption is inversely proportional to the rating of the bulb. The power consumption is inversely proportional to the rating of the bulb. This is the observation during in series connections. Similarly, power consumption, this is 1. The power consumption 2 is inversely proportional to 1 by P. In series connection of bulbs, the power consumption is inversely proportional to the rating of the bulb. Power consumption is inversely proportional to the rating of the bulb. That is, if rating of the bulb is increases, what is the power consumption, friends? If rating of bulb is increases, if rating of bulb is increases, this one. If the rating is increases, what is the power consumption reduces? Power consumption is reduces. Rating of bulb is increases, the power consumption is reduces. This total power consumption is I square into R1 plus I square into R2. Then if VR equal to V, if VR equal to V, that is each rating of the bulb, the rating of each bulb equal to rated voltage. The rating of each bulb equal to rated voltage. So for example, there is a two bulbs are connected like this. I apply the 230 volts supply voltage. Let each bulb rating is also 230 volts. I'm not talking about voltage across each bulb. Each bulb rating is also equal to rated voltage. Then in that case, if VR equal to V, then the total power consumption, you substitute I value here, take VR equal to V splits. Substitute I value here, that I'm leaving for you. Substitute I value here and take VR equal to V. Take VR equal to V and simplify that and write the P1 equal to V square by R1. Write the P2 equal to V square by R2. Then finally we can get the total power consumption equal to P1 P2 by P1 plus P2. I'm writing the power consumption in terms of the power ratings. I'm writing the power consumption in terms of the ratings of the bulbs. So concept very simple. You can try this one. This I'm leaving for you. I square into R1 plus I square into R2. Na? Substitute I formula here. And replace VR equal to V. Replace VR equal to V. And write down V square by R1 equal to P1. V square by R2 equal to P2. Then what the total power consumption in a series connection? The total power consumption in series connection is not the sum of the two power ratings. This is P1 P2 by P1 plus P2. This is in series connection. Very important observation, students. In series connection, power consumption is inversely proportional to the rating of the bulb. That means the bulb which having the higher rating, that bulbs consumes the less power. And one more important, in series connection of bulbs, the bulbs having the lower power rating has brighter glow. Lower power rating is having the brighter glow. In series connection of bulbs, the bulb having the lower power rating has brighter glow. Why? Can anybody? The bulb having the lower power rating, is a brighter glow. The reason is this one. If power rating is less, power consumption is high. It is taking more power means what are the brightness? The brightness is also more. It is taking the more power. It consuming the more power means then the brightness is also more. This is the reason. If power rating is low, power consumption is high, then brightness is high. Yep. That's why in series connection of bulbs, the bulb having the lower power rating has brighter glow. For example, 40 watt bulb, 80 watt bulb is connected in series. Then which bulb will glow brighter? Can anybody? Same rating, same voltage rating bulbs, 40 watt bulb and 80 watt bulb is connected in series. Which bulb is more brighter? Which bulb glow with more brightness? Is 40 watt bulb or 80 watt bulb? I'm expecting answer from you. 40 watt bulb, 80 watt bulb with the same voltage rating, are connected in series, then which bulb glows brighter? What is your answer, sir? Which bulb glows brighter? 40 watt bulb or 80 watt bulb? The power rating is low, the brightness is more. That's why 40 watt bulb will glow brighter as compared to 80 watt bulb in a series connection. That is how to concept. Here I taken this condition is applicable if the rating of the bulb is equal to supply voltage. This before this, I'm giving this note point. Just a minute. See, for this, if you want proof, I'm giving the proof also, friends. Note here I given total power consumption equal to I square into R1 plus I square into R2. Correct? This is equal to, take I square is common, R1 plus R2. Then what is I? Is I equal to V R by R1 plus R2 whole square into R1 plus R2. Clear? But let voltage rating of each bulb, voltage rating of each bulb is equal to supply voltage. Voltage rating of each bulb equal to supply voltage. Yes, that is V equal to VR. Then you replace that one, V by R1 plus R2 whole square into R1 plus R. R1 plus R. This shall you can write like this, V by R1 plus R2 whole square into R1 plus R2. Then by simplifying this, we can get this is P1 P2 by P1 plus P2. This is the total power consumption. Here I taken V square by R1 equal to P1, V square by R2 equal to P. This is V square by R2 equal to P2. You have to replace this. Then PT equal to P1 P2 by P1 plus P2. If two bulbs are connected like this, if any number of bulbs are connected in series, for example, if any number of bulbs are connected in series, if any number of bulbs are connected in series, and so on, please connect it like this. Then let the VR equal to V. The voltage rating, the supply voltage rating equal to rating of each bulb. Then this is P1, this is P2, this is P3, and so on. Then what the total power consumption here? 1 by PT equal to 1 by P1 plus 1 by P2 plus 1 by P3 plus, and so on. Like this you have. This is the total power consumption. Total power. This is the observation if the bulbs are connected in series. Very important, three observations here. If the bulbs are connected in series, one is power consumption is inversely proportional to the rating of the bulb. The second one is in series connection of bulbs, the bulb having the lower power rating has brighter glow. The bulb which is lesser rating, that bulb is more brighter. If actual power consumption is greater than power rating, the bulb will. If actual power consumption is greater than power rating, students, the bulb will blow the fuse. If actual power consumption is greater than the power rating, the bulb will blow the fuse. Blow the fuse. That's why always the power consumption must be less than the power rating. If the actual power consumption is greater than the power rating, the bulb will blow the fuse. Clear? Always the power consumption must be less than the power rating. Otherwise, it will be damaged. At that point, you have. Next, what are the parallel connection of the bulbs? What are the parallel connection of the bulbs? Let's consider two bulbs are connected in parallel. Let's consider two bulbs are connected in parallel. Two bulbs are connected in parallel. Connected in parallel. And this is the bulb 1. And this is the bulb 2. This bulb 1 and bulb 2. These two bulbs are connected in parallel. Let the rated voltage is VR. The supply voltage. How much rated supply voltage is VR? Bulb 1 rating is the bulb 1 rating. The bulb 1 rating is power rating is P1, voltage is V. The bulb 2 rating is power rating is P2, voltage is V. Power rating is P2, voltage is V. Then what is the resistance of bulb 1? Resistance of bulb is calculated from the rating of the bulb. This is important. Resistance of bulb 1, that is R1 equal to, that is V square by, how you can write this? V square by P. What is the resistance of bulb 2? Resistance of bulb 2. The resistance of the bulbs are calculated from the ratings. This is important. R2 equal to V square by P2. V square by P2. Now in this case, what is the power consumed by bulb 1? What is the power consumed by bulb 1 students? power consumed by bulb 1. The power consumed by bulb 1. P consumption 1 equal to the power consumed by bulb 1 is VR square by R1. VR square by R. Sir, why you taken VR square by R? It's very important here. In parallel connection, voltage is constant. Voltage across this bulb and voltage across this bulb is equal. That is, in parallel connection, voltages are equal. That's why the power consumption is depends on the voltage. But in series connection, which is constant here? Current is constant. The power consumption I written in terms of the currents. But here I taken with respect to voltages because it is a parallel connection. That is power consumption of bulb 1. This is very important, main difference here. What is the power consumed by bulb 2? The power consumed by bulb 2. If you have to write in terms of current, each bulb current you have to calculate. But voltages are equal, that's why I'm taking this one. That is VR square by R2. VR square by R. Then what is the observation here? What is the total power consumption? The total power consumption equal to the total power consumption. How to write? The total power consumption equal to, that is P consumption 1, that is power consumed by bulb 1, power consumed by bulb 2, VR square by R1 plus VR square by R. Let assume, with this assumption only these formulas are applicable. VR equal to V. That means the rating of each bulb equal to supply voltage. The rating of each bulb equal to supply voltage. That is the condition. With this assumption only, but every time you don't expect like that only. But this formula is applicable with this assumption only. Let assume VR equal to V means the rating of each bulb equal to supply voltage. Then what is PT equal to, friends? That is V square by R1 plus V square by R2. What is the V square by R1? This V square by R1 equal to P1. What is V square by R2? V square by R2 equal to P2. This is equal to P1 plus P2. That is, in parallel connection, the total power consumption equal to sum of the ratings of the bulbs. The total power consumption equal to sum of the ratings of the bulbs. See this one. But here the total power consumption is not sum of the ratings directly. P1, P2 by P1 plus P2. But here we are getting P1 plus P2 directly. Clear, friends? But the assumption is let VR equal to V. The rating of each bulb is equal to supply voltage. What is the meaning of this one? The rating of each bulb equal to supply. Then only you apply this formula. Each bulb is equal to supply voltage. Is equal to supply voltage. Supply voltage. Then one more observation here. What is the power consumption? The power consumption is proportional to VR square by R1 students. The power consumption is proportional to VR square by R1. That means what is the observation? VR square by R1. How to write like this? VR square by R1. This is proportional to VR square by, what is R1? R1 equal to V square by P1. V square by P1. Then power consumption is proportional to, that is VR square by V square into P1. You bring this P1 into the numerator. Then what is the observation here? Power consumption is proportional to P1. Similarly, power consumption is proportional to P2. Exactly opposite, friends. In series connection, power consumption is inversely proportional to the rating of the bulb. But here, power consumption is directly proportional to the rating of the bulb. That means, what is the observation here? If rating of the bulb is increases, what the power rating is also, power consumption also increases. In parallel connection, the bulb having high power rating glows brighter. If the higher the power rating, higher the power consumption, if any bulb takes the more power, it glows more brighter. Glows more brighter. Therefore, in parallel connection, if bulb rating is increases, power consumption is increases, power consumption is also increases. It's very important observation. Power consumption is increases. Then what is the brightness? The brightness also increases. The bulb which is having the high power rating, that bulb glows more brighter. That is in parallel connection. Series connection, 40 watt, 80 watt, which is more brighter? 40 watt is more brighter. Parallel connection, 40 watt, 80 watt, which is more brighter? 80 watt bulb is more brighter. This arrangement we have to see in our domestic application. In domestic applications, the bulbs are connected in parallel only. Why? See, one problem is, yes friends, in series connection, if you connect the more number of loads in series, if any one load is damaged, then there is no current to another load. Then total system is interrupted. That's why we don't prefer the series connection. If one bulb is not glow, remaining bulbs also not glow. That's the reason why in domestic application, the bulbs are arranged in not in series connection. They are arranging in parallel connection. That is in domestic application, parallel connection of bulbs are used. That's the reason why you seen in the domestic application, the bulb which is high rating, that bulb glows more brighter. Yes or no? Yeah, this I am writing notes to this. In domestic applications, the parallel connection of bulbs are used. Parallel connection of bulbs are used. Bulbs are used. Yes. Yeah, this about series connection and parallel connection. This I'm writing summary. If you take series connection of bulbs, and you take parallel connection of bulbs, One is, it may be series connection or parallel connection. R equal to V square by P. This P equal to V square by R. Here also same. R equal to V square by P. Then P equal to V square by R. Next, the total power consumption equal to total power consumption. The total power consumption equal to, so that is P1 P2 by P1 plus P2. If more number of bulbs are connected in series, 1 by P1 plus 1 by P2 plus and so. Then what the total power consumption equal to? P1 plus P2 plus and so on. Any number of bulbs are connected in parallel. Power consumption is inversely proportional to the rating of the bulb. But here, power consumption is directly proportional to the rating of the bulb. Next, bulb with a lower rating glows brighter. But here, bulb with a higher rating glows brighter. If one bulb is open circuit, remaining bulbs not glow. If one bulb is open circuit or damaged, then remaining bulbs glow. There is no problem. Bulbs glow. Not preferred for domestic applications. But which is preferred for domestic application? This is parallel connection is preferred for domestic applications. Parallel connection is preferred for domestic applications. Yeah, these points mainly for to consider. Now, with this knowledge, two incandescent bulbs of 40 watt and 60 watt rating are connected in parallel across the main supply 230 volts 50 Hz. Which bulb resistance is more? Which bulb filament thickness is more? What is the power consumed by each bulb? Total power consumed by the bulbs. Which bulbs glows bright? Totally 1, 2, 3, 4, 5 questions are there. These are the possible questions. Yes. First question answer I am writing. That is 60 watt, 40 watt. That is let P1 is 40 watt rating. Let P2 equal to 60 watt rating. These are ratings of the bulbs. Let assume that supply is 230, then voltage rating is also 230. If each bulb voltage rating is not given, let VR equal to V equal to 230. With this assumption only you can solve. If they given separate voltage ratings, according that you take. But here supply is given, the rating voltage ratings of the bulbs are not given. You take the supply voltage is the voltage rating of the each bulb. Source. Then you have to calculate what is R1 and R2. Then R1 equal to, that is P1 square by V, R2 equal to P2 square by V. Actually here V is same, but you know that P2 greater than P1. If P2 greater than P1 means R2 greater than R1. No need to calculate the values. R2 greater than R1. That's why, which bulb resistance is more? This P2 greater than P1. This V denominator is same. Which is greater? P2 is greater. P2 is greater than R2 is greater. Then bulb 2 is high resistance. Which bulb resistance is more? Therefore, bulb 2 resistance is more. Clear? Next. What the B question? Which bulb filament thickness is more? Students, we know that R equal to rho L by A. Rho L by A. If the resistance is high, thickness is less. The area is less. That is thickness is less. Then, if the R2 is greater than R1, Then what about A2 is less than A1? A2 less than A1. That is 60 watt bulb thickness is, that is P, that is bulb 2. I taken 60 watt bulb is the bulb 2. That is the bulb 2 filament thickness is bulb 2. That is which bulb thickness is more here? Which bulb filament thickness is more? R2 greater than R1, no? Which is high resistance, friends? Which is high resistance? P is less, R is more. Just a minute. But voltages are equal here. I'm taking this one. Just a minute. It's the series connection. The current is constant. So wrong assumption here. Just a minute. Please correct it. P1 is 40 watt. P2 is 60 watt. No? P equal to V square by R. High the resistance. If the resistance is high, bulb brightness is, if the resistance is high, the power rating is less. Which bulb is power rating is less? 40 watt bulb. That's why 40 watt bulb is high resistance. This is important. Please, 40 watt bulb is high resistance. You have to decide this resistance according to power rating. 40 watt bulb is high resistance. That is 40 watt bulb is I taken. This is P1. Bulb 1 is high rating. 40 watt bulb is bulb 1 students. I'm assuming that is a bulb 1. 40 watt bulb is high resistance. Now tell the students. If the 40 watt bulb high resistance, that is R40 is greater than R60, then A40 is less than A60. That is 60 watt bulb filament thickness is more. 60 watt bulb, please correct this one. You have to decide the resistance based on the power rating. Then resistance is high, power rating is less. 60 watt bulb, 60 watt bulb, 60 watt bulb, filament thickness is more. Filament thickness is more. Filament thickness is more. 50 watt bulb filament thickness is more. Next, what is the C question? What is the power consumed by each bulb? How to calculate the power consumed by each bulb? It is in parallel connection. No? This is in parallel connection, sir. I told already. Parallel connection not according to current, according to voltage only. That's why you decide like this. P equal to V square by R. Then what is the power consumption for each bulb? What is the power consumed by each bulb? P consumption 1 equal to, it is a parallel connection. No? V square by R1. V square by R. That is 230 square by 230 square by. What is the R1 you can write? We don't know about R1. How to calculate R1? I told already resistances are calculated by using the power rating on. How to calculate R1 equal to V square by P1. To substitute here 230 square by R1. I'm writing V square by P1. This is V square by P1 students. Then what is the power consumption 1? That is 230 square by 230 square by what is the P1? P1 equal to 40 watt rating. Then what is the power consumed by bulb 1? 40 watt bulb is equal to 40 watt. Because here the VR equal to V. That's why you are getting same answer. You taken VR equal to V students. That's the reason why you are getting. That is power consumption 1 equal to 40. That is 40 watts. That is 40 watt. Then what is the power consumed by bulb 2? Power consumed by bulb 2. P consumed 2. That is V square by R2. That is V square by R2 equal to how you can write V square by P2. This is equal to P2. This is equal to 60 watt. Then what is the total power consumption? What is the power consumed each bulb? Total power consumed by the two bulbs. The total power consumption equal to, this is question number T. The total power consumption equal to P1 plus P2. That is 40 plus 60 watts. This is equal to 100 watt. The total power consumption is 100. Which bulb glows brighter? Can anybody answer? Which bulb glows brighter? It is a which connection? Parallel connection. No? In parallel connection, the bulb which is higher rating, that bulb glows brighter. No? The bulbs which is higher rating, that bulb glows brighter. Then 40 watt bulb or 60 watt bulb? Which bulb glows brighter? That is the question. 60 watt bulb glows brighter. Glows brighter. Clear, friends? Like this, you have to calculate. Okay, this is a question based on the parallel connection. Can you try this one? Series connection. Ladder. Type A bulb 12 volt, 12 watt. Type B bulb is 12 volt, 24 watt. Type C bulb is 24 volts, 24 watt. How many extra Type C bulbs can be connected to the supply without blowing the fuse? We have to calculate what the resistance of each bulb, students. Calculate the resistance of each bulb. Then what is the bulb A resistance? The bulb A resistance equal to, that is V square by P na, that is 12 square by 12. This is equal to 12 watt, 12 volts now. This is 12 ohms. What are the resistance of bulb B? What are the bulb B resistance? This also same V square by P. Yes, friends. That is 12 square by 24. This is how much you can get, 6 ohms. What the resistance of bulb C? The resistance of bulb C, V square by P, that is 24 square by 24. This is equal to 24 ohms. That is, bulb A resistance is 12 ohms, bulb B resistance is 6 ohms, bulb C resistance is 24 ohms. That this is 15 ampere fuse. It is given 15 ampere fuse. This is bulb A resistance is how much? 12 ohms. Bulb B resistance is how much? 6 ohms. Bulb C resistance is how much? 24 ohms. This is 24 ohms. This is 12 volts. This how much current it is given? 15 ampere. The current is 15 ampere. Is a 15 ampere fuse? It is a 15. Sorry, it is a 15 ampere fuse now. The current is not 15 ampere. This is a 15 ampere fuse, students. Not the current is not 15 amperes. The fuse rating only it is given 15 amperes. It's a 15 ampere. Now, can you find what is this current and this current and this current, students? You have to calculate those currents. What is this current and what is this current and what is this current? That is 12 by 12 now. This is 12 volts here. This also 12 volts here. Here also 12 volts. Then 12 by 12 now. This is equal to 1 ampere. 12 by 6 now. It is equal to 2 amperes. 12 by 24 now. This is equal to 0.5 amperes. Clear? This is 1 ampere. This is 2 ampere. This is 0.5. The total how much current it is drawing? How much current it is drawing? This is 1 ampere. This is 2 ampere. This is 0.5 amperes, means 3.5 amperes is drawing. If 3.5 amperes it is drawing, then still how much possible current we can supply? According to these resistances, these 3 bulbs are drawing only 3.5 amperes. Still, how much current this fuse can withstand? Then still, the fuse can withstand. The fuse can withstand how much current, students? Still, the fuse can withstand 15 minus 3.5. 11.5 amperes it can withstand. Approximately, it is withstand 11.5 amperes. Even though we can add the extra bulbs also, the fuse can withstand. But up to what current it can withstand? Extra 11.5 amperes it can withstand. Here question is asking, how many extra C bulbs can be connected to the supply without blowing the fuse? C bulb can drawing how much current? 0.5 amperes. 0.5 amperes, 11.5 amperes can withstand. The fuse can withstand 11.5 ampere extra, but each bulb is 0.5 ampere only. Each bulb is 1. That is, you have to, for C bulbs, here it is asking that C bulb only. For C bulbs, the number of bulbs into NC into each bulb rating is 0.5. Sorry, each bulb, that each C bulbs can carry the 0.5 ampere. NC into 0.5 less than or equal to 11.5. This is the number of C bulbs I am calculating. Number of, don't connect greater than 11.5. Less than or equal to, that is number of C bulbs. Then from this, how many number of C bulbs? Less than or equal to 11.5 by 0.5 students. Then NC less than or equal to is approximately how much you can get? Can you answer that? This NC is less than or equal to 23 bulbs. 23 are less than 23 only. Then less than or equal to 23 means best selection is 22 bulbs. Understand the question, friends? Here, type A, type B, type C. 3 bulbs are connected in parallel. Type A bulb is carrying 1 ampere. This voltage by this resistance. This voltage by this resistance. This voltage by this resistance. Fuse rating is, this is not the input current. 15 ampere is the fuse rating. All these 3 bulbs, how much current it is drawing? 3.5 amperes. But fuse can withstand 15 amperes. But it is drawing only 3.5. Still, how much current it can withstand? 11.5 ampere can withstand. The question it is asking, how many extra type C bulbs can be connected to the supply without blowing the fuse? Without blowing the fuse means current must be less than or equal to 15 ampere. If the current drawn from the source is greater than 15 ampere, the bulb will be fused. That's the reason why you subtract 15 minus 3.5, 11. Corresponding to 11.5, you calculate the number of C bulbs. The number of C bulbs is less than or equal to 23. The best selection is 22. Yes, friends. This extra number of C bulbs, not the A bulbs, and A bulbs are different. If you want A bulbs means NA into each bulb is how much? 1. NA into 1 less than or equal to 1 point. If you want B bulbs means NB into each bulb is carrying how much? 2. NB into 2. Like that you calculate. But here asking only C bulbs. Extra how many C bulbs? Extra C bulbs you have to connect 23. Then fuse will not flow. Because it can withstand up to 15 amperes. It can withstand up to 15 amperes. That is the reason. Clear? Yeah, this you have to concentrate. These are the question based on the series connection, parallel connection. I am giving this question for homework. This is the question based on the series connection of the bulbs. Have to try it. Two incandescent bulbs. Two incandescent bulbs. 40 watt and 60 watt rating are connected in series. Are connected in series. The supply voltage is 230 volts 50 H. Then calculate. That is a question. Which bulb is high resistance? Which bulb is high resistance? High resistance. B question is which bulb filament is high thickness? Filament is high thickness. High thickness. Next. The C question is how to take what is the power consumed by each bulb? Power consumed by each bulb. Consumed by each bulb. By each bulb. D question is what is the total power consumption? Total power consumption. Total power consumption. Which bulb glows more brighter? Which bulb glows more brighter? More bright. I am solving this question. A question and B question is similar to parallel connection, no change. P equal to V square by R. If the resistance is high, power rating is less. That is, a 40 watt bulb resistance is high resistance as compared to 60 watt bulb. Even B question also same. R equal to rho L by A. If the thickness is low, resistance is high. Then R40 greater than R60. Then A40 less than A60. 60 watt bulb. Filament thickness is more. Filament. These two questions are same for both problems. Filament thickness is more. Filament thickness is more. Next, C question. How to calculate power consumption, friends? In series connection, you have to calculate power consumption based on the current. I square into R1. Correct? The power consumption equal to, in series connection, you have to calculate I square into R1. Then, how to calculate R1? R1 equal to V square by P1. How to calculate I equal to V by R1 plus R2. I equal to V by R1 plus R2. Then, how to first to calculate R1? V square means 230 square by, what is the P1? P1 is 40. That is 230 square by 40 is approximately equal to 1322.5 ohms. What is R2 equal to? V square by P2. That is 230 square by 60 ohms. Is approximately how much you can get? 881.67. 67 ohms we get. Now you have to calculate the current. Then I equal to 230 by 1322.5 plus this is 881.67. Is approximately equal to 0.104 amperes we get. Then what the power consumed by bulb 1? Power consumption of bulb 1 equal to 0.104 square into R1, that is 1322.5. This is equal to 14.4 watt. What the power consumed by bulb 2? Bulb 2 power consumption is 0.104 square into R2. R2 is how much, friends? 881.67. This is 9.6 watt. That is, this bulb is consuming 14.4 watt. This bulb is consuming 9.6 watt. Then what is the total power consumption? The total power consumption equal to, you take P consume 1 plus P consume 2, or you apply P1 P2 by P1 plus P2. You can get same answer. You take power consumption 1 plus power consumption 2 or P1 plus P2. If you want, check it. This is 14.4 plus 9.6 volts. How much you can get? This is 1524 watt. If you want, try this one. P1 P2 now 40 into 60 by 40 plus 60. Then also you can get same answer, 24 watt. You can like this or like this also you can get the same answer. Then which bulb glows more brighter? Can anybody? Which bulb glows more brighter? C question is over. There's D question also over. Which bulb glows more brighter? It is a series connection now. In series connection, the bulbs which is lower rating, that bulbs more, that is 40 watt bulb glows more brighter. 40 watt bulb glows more bright. Why, friends? It's very simple. You have to check it. For 40 watt bulb, what is the power consumption? 14.4 watt it is taking the power. That's why it is more brighter. Inversely proportional. Na? Power consumption is inversely proportional to power rating. If the power rating is less, power consumption is more. 40-watt bulb is more power consumption. That's why 40-watt bulb glows more brighter. Lower rating, the bulb which is having the lower rating, that bulb more brighter, glows more brighter in series connection. This is proof. That is 40-watt bulb is consuming 14.4 watts of power. That 60-watt rating bulb is consuming only 9.6 watt rating of power, 9.6 watts of power only. That's why, which is high power consumption? Bulb 1 is, that is 40-watt bulb is high power consumption. That's why it is glowing more brighter. 40-watt bulb glows more brighter. Clear, friends? This is about the concepts of bulbs are connected in series and parallel. Then how to solve the problems in a infinite grid case. The next session will start with very important concepts with respect to network theory, that is nodal analysis and mesh analysis. With that, chapter 1 will be complete. Then before that, we'll see some other models of questions, some questions based on KVL and KCL, and some questions based on the, if that is cube is given, how to solve the problems. After completing that, you'll have to see nodal analysis and mesh analysis. With that, chapter 1 will be next 2 sessions, maximum chapter 1 will be complete. Thank you. This is about the today's session. Any doubt? Okay, I will share this PPT in Telegram channel. Please select once again. Please go through the whatever the concept I explained. Thank you. Ending the session.